Welcome back to Cajun Coding. This is St. Raz, and we are still doing Java warm-up section 1 on the Codingbat website. Just one quick thing before we get started. I was thinking to myself, is this the very, very best way you could possibly learn how to program? And in all humility and realism, it is probably not, and that's okay. I don't want you guys to get hung up on the idea that you want to learn in the very, very best possible way and spend all your time and cognitive resources and opportunities in looking for the very, very best way to learn how to program. Because if you find yourself learning in the second best way, or the fourth best way, or the eighth best way, or the 100th best way, if you're working less efficiently than you could be, but you're still working, you're still practicing, you're still progressing, then you're making headway better than someone who is still on that search for the very best possible way they could learn. So, as Voltaire said, do not let the perfect be the enemy of the good. So, with that said, let's go ahead and start working. Like I said, we're in the Warmup1 section for Java on the Codingbat site. And the exercise is del. I guess that's how we're going to pronounce that. Given a string, if the string del appears starting at index 1, return a string where that del has been deleted. Otherwise, return the string unchanged. Now there's a little trap there. If you're paying attention, what's that trap in the very first line there? If you've practiced this exercise, if you've attempted it, you probably already know what I'm talking about. Look here, index 1. Now we've dealt with initial substrings of a given string, but this index 1, starting at index 1, del is not going to be our first three letters. It's rather going to be letters, the second through the fourth letters in that string, not indices 0 through 3. Rather, that substring is going to be 1 through 4. So return the string with that del deleted if that is the substring there. So if, and our given string is str, string substring 1 through 4, not 0 through 1. And we're going to check to see if it's that del. What's that method there? Equals. Remember to put the double quotes there, del. Okay, remember that second parentheses there to close the if. And what we're going to do is going to return that string where the del has been deleted. Now we know the indices here. Okay, so we know we're going to send that first character, and let's just mix it up a little bit and use the character at index 0. And we're going to return a string consisting of multiple parts, perhaps. So let's use the concatenation operator. And then string substring. Now if we want the complete remainder of a string, we can just give it an index. So we start at 4 there. And what if that's not the case? If we don't have that del in there. Otherwise, return the string unchanged. That part's easy. So we just return the string unchanged. Now we've been through this a little bit, looking at these strings and such. What are some of our edge cases? What are some of the things that can go wrong? Now we've talked about that. It's those out of bounds exceptions that we've got to look out for. So let's make sure our string is long enough. Now, if del, that's 3 characters long, and it starts at index 1, then that means that our string is going to have to be at least 4 characters long. So let's check on that first. So str length is greater than or equal to 4, and then we check to see if that substring is in there. Now if the string is less than 4, because we have got the AND operator here, if this is less than 4, this statement is not even going to be read by the compiler, and it's going to skip over this code. So if this is less than 4, we don't have to worry about this. So we shouldn't get an exception. And there we go. And our next exercise. I didn't start my timer this time. Let me go ahead and start that now to make sure we don't go over. I think we've only a few minutes in here. And our next exercise is mix start, whatever that means. Let me see. Return true if the given string begins with mix, except the m can be anything. So pix, 9x, all count. Now I'm wondering about this mix thing, and I think this is just an exercise. This is kind of a cognitive trap, but it's not really that cheeky, because as a programmer you're going to be faced with some things that constitute superfluous information, and in most cases it's probably okay to tell a supervisor or a client or other person you're communicating with, give us all the information you think might be necessary. It's kind of a programmer's job to ignore the stuff that's not relevant. And in this case, this character right here, that m is irrelevant. If the string begins with mix, except the m can be anything, so we're really not asking about what the string starts with. It doesn't matter. What matters is that second and third character, those characters at indices 1 and 2. We just ignore the 0. So, and this is a Boolean. This returns a Boolean, so it's true. So for the case of being succinct, we can just return. And what are we returning? Let me see. First, let's make sure we don't get an out of bounds exception. So we return str length is greater than 2. 3 characters is long enough. It's not a problem. But if it's 2 characters, then that could be a problem. So actually it should be, greater than 2. If it's 2 characters, that's a problem. So it has to be greater than 2. And str substring, and this is 1 to 3, and we use the equals. Remember the double quotes, ix, and that should do it, and it does. And you see their solution. That's a bit more verbose, isn't it? Okay, so if string length is less than 3, return false. That's checking our edge case, which we did right here. If string equals 2, this is not an if statement. This is an assignment. Okay, string dot substring 1 to 3 equals string 2. So they're assigning that substring to the variable 2. If 2 equals, in 2, this is the substring they just created. If string 2 equals ix, return true, else return false. Okay, and they're saying that last part can be shortened to return 2 equals ix, or we can shorten the whole thing to what we have right here. I'm not trying to golf this excessively. This is not obscurely compacted. You know, this is pretty succinct. But The idea is you should be able to look at this and you should be able to follow this and understand how both of those are arriving at the same solution. And on to the next one. Start Oz. Given a string, return a string made of the first two characters if present. However, include the first character only if it is O, and include the second only if it is Z. So Ozymandias yields Oz. So I think in this case we're going to go ahead and create a string for our answer. String, and we'll just call it answer. YBQ with it. Answer, and we're going to initialize it as an empty string. So we've got the variable name, we've got the spot in memory, but we haven't put anything in there as a value. So what's our first part? Okay, if, and this is our given string that was passed in, string, and we can use character at. The important thing about the character at, use single quotes when you're checking a character. Oops, character at, actually 0 index. Okay, and I'll look at those quotes in a moment. I was about to tell you something I was mistaken. If string dot character at 0 equals, and we use single quotes here, and then we're closing our if. Now, important thing to note, when we check a character at, we use the arithmetic operator here, the equals. We don't use the dot equals method, so bear that in mind. So if string dot character at index 0 equals O, then we're going to add that to the answer. And here's the conventions important to know. See this plus equals? That is a form of the assignment operator. And what that does is that's doing the exact same thing that answer equals answer plus O. These are logically identical. This one is a little shorter. This one says the answer is whatever the answer was before plus the letter O. This one is doing the exact same thing, but we're just noting we're going to append O to whatever answer was before, which is in this case an empty string, so it's going to set it to O. And we'll go ahead and get rid of this. Now, whether this is true or not, whether we're adding that O or not, we may still be adding a Z. So this is not an else, this is just a different if. At index 1 equals Z. I made a syntax error in the above if block. Go ahead and look at that and see if you can see what it is. Answer plus equals Z. And then when we're done with that, we're just going to return answer. Did you see the syntax error in the top if block, if statement? If statements don't end with a semicolon. We don't need that. Now these statements do end with a semicolon. Most statements do. However, the contents of the conditional in the if statement does not. We have another problem too. See if you can spot that. What's the most common error we get? Most common error is going to be, look over here, out of bounds, isn't it? And there it is. String index out of bounds. So we can fix that very quickly. If this is going to run, we have to have a string of length at least 1. So if string length is greater than 0 and string character at index 0 equals O. In this case, we're looking at the second one. Since we're looking at the second one, string length is going to have to be greater than 1. And this should fix everything there. Oh, what happened? Can I find symbol length? Very careful stretching string line 3. What went wrong? Right here. And there we go. Int max. Given 3 int variables A, B, C, return the largest. Okay. Now this isn't hard to do, but I'm going to go ahead and go do this the long way, and then we'll show you how to do the rest of it. So let's declare an int temp and we're not going to give it a value yet. We use an if statement. If A is greater than B, then temp equals A, else temp equals B. If C is greater than temp, return C. So we're putting temp is going to be the greater of A and B. If A is greater than temp's A, if B is greater than temp is B. If C is greater than both of those, then we'll return C. And we need to return if not, else. If A is greater than B, return A, else return B. And that works. Seems like a lot of work, actually. There's a function that we can use to speed this up a lot, and they're probably going to use this in their solution. It would be the max math method. And there it goes, int max. And let me see, public int max. Oh, I'm sorry, that's not the method that we're talking about. Actually, this is the long way that we just showed, and they're using max instead of temp. And they could have streamlined that a little bit. Actually, it looks like a little bit more streamlined. But notice here it says you can use the built-in MathMax function. Now, MathMax only supports 2 inputs, so you're not going to be able to pass all 3 in there. But you can use that as a quick way to find the larger of 2 inputs, and then you only have the response to that to compare to the third. And we're going to be having plenty of time to use that in the future. The syntax for that would be math.max, and then you place the variables in there, x, y, and that returns whichever one of those is the largest. And close 10, or close 10. Given 2 integer values, return whichever is nearest to the value 10, or return 0 in the event of a tie. Note that math, absolute, n returns the absolute value of a number, and of course the n can be an arithmetic operation as well. So, as is usually the case, we'll go ahead and return 0 in the event of a tie. Let me see. So if math abs n minus 10, actually it's going to be a, we've got a and b, is equal to math abs b minus 10, return 0, else, and here we're going to return the one that is nearest. So we're going to be looking for the one that's nearest would be the one that has the absolute value. Is going to be nearest to 0. So we've got math and our variables here will be math Now I think this is not going to work. I'll explain that in a moment. Okay, so these return 0. So this top part is correct. Okay, but what's going on here? It says, let's see, return whichever value is nearest to the value 10. Okay, what's going on here? 8, 13. We're expecting 8 because 8 is closer to 10 than 13. But what are we getting? We're getting 2. What's returning is the absolute value, not the number which is generating that lowest absolute value. And this demonstrates the importance of making sure that you're getting the right answer. You're not just giving the answer that's correct to the question you interpret, but the question that's actually being asked. Okay, so that first part is right. So if they're equidistant from 10, it returns 0. So that part's right. It's this block that we need to fix. Okay. So how do we fix that? Here's something. So we're going to compare these. If math absolute A is less than 10, okay, so if the absolute value of A minus 10 is less than the absolute value of B minus 10, return A, else return B. Make sure my enclosures are right. Yes, they are. Now this is what we're doing here. Okay, we're looking at one that's closest to the number 10. That means that the absolute value is going to be less. So if our absolute value for A is less than B, then we return A. The only other possibility is that they're the same, but we've already accounted for that in this block, or B is less, so we don't need all this logic. It's either A or B. We've already accounted for the tie, and that successfully solves the problem. Okay, in 3050, given two integer values, return true if they're both in the range 30 to 40 inclusive, or they're both in the range of 40 to 50 inclusive. And we've done a lot of problems just like this, so this should go pretty quickly. Return true if both are in 30 to 40, so A is greater than or equal to 30 and A is less than or equal to 40, and they both have to be in the range, so B is greater than or equal to greater than or equal to 30, and b is less than or equal to 40. Okay, now this is kind of half of the problem. We can enclose this entire statement in the parentheses there, and then use the OR operator. This is the inclusive OR, and a is greater than or equal to 40, and a is less than or equal to 50, and b is greater than or equal to 40, and b is less than or equal to 50. And I believe that should do it. There it is. Conceptually not very complicated. A lot of comparisons there, but that one's actually pretty easy. For readability's sake, you can do this and maybe move that over a little bit so you can see that these statements are almost the same, except for these small changes there. And of course you can use cut and paste if you need to. Java is blind to white space, your spaces, your tabs, your returns. The compiler doesn't see any of those. So if you can change around the code to make it easier to look at, easier to read, and in statements that are extremely long, say you've got a statement 160, 180 characters long, a lot of folks, a lot of industries, or a lot of companies or shops will have a standard of, we don't want lines to be longer than 80 characters because they get too difficult to read. And if you find a good spot to break up code like this one, where this section is almost the same as this section, go ahead and break those up and put them right next to each other so you can compare them very easily. A lot of code is there for the benefit of human beings, not machines. Max1020, given two positive integer values, return the larger value that is in the range 10 to 20 inclusive, or return 0 if neither is in that range. Now it says or return 0, so maybe we should go ahead and check that first. So if neither is in that range, so if a is not in that range, so if a is greater than 20, it's not in that range. Or if a is less than 10, it's not in that range. Neither is in that range. That would be an and. We make sure neither of those is in that range. So b is greater than 20 and b, or b is less than 10. Now we need to watch there's a lot of comparators here, and it's easy to get things messed up here. So let's go ahead and make sure we break these up a little bit using these parentheses. Now this parentheses closing here is closing this, which leaves our if without enclosure. So this is our entire if conditional here. Now if neither is in that range, then we're returning 0, so we will return 0. And on to the rest of our problem. Else. Okay. Given two positive integer values, return the larger value that is in the range range 10 to 20 inclusive. 0 is neither in that range. So we look at a possibility here. We could have one that's within that range, or we could have two. So what we need to do is make sure that we are returning a valid value. So what we could do is, if a is greater than b and a is in the appropriate range, greater than or equal to 10, and a is less than or equal to 20, return A. And I think I made a mistake here. Because we have a problem here. No, I think this will work. Else. Yeah, we have run into a problem there. It's returning 21. A is not bigger, and that's our problem here. See, so A is not bigger than B, but A is in the proper range. But since A is not bigger than B, it goes down here, return B. So we could check to see if B is in the proper range. But this if block has already kicked us out of possibly returning A. So if B fails, we're not going backwards to A. So what are we doing here? What we could do is set up a variable, and it says return the value. Okay, it doesn't have to tell us, we don't have to know whether it was the value was A or B. Okay, whether that was originally A or was originally B doesn't matter, it just needs the value. So what we're going to do is possibly swap out the values. So if A is greater than B, int temp for temporary is going to equal A. Oops, sorry. We need to make sure that A is greater than B. So if A is less than B, so do int temp equals A. I'm sorry, I said equals. This is actually the assignment operator. A, we're going to assign to A B, and then we're going to assign to B the original value of A, which we held in our temporary variable. Okay, so what we've done, A needs to be greater than B. If A is not greater than B, then we're going to swap the two around. So now we know that A is bigger. Now, having done that, what we're going to do is, if A is greater than or equal to 10 and A less than or equal to 20, then we're going to return A. Otherwise, we return B, and that should do it. And there it is. Okay, going over this a little bit. Now, if A is in the proper range, then we return it. Okay, now we know A is bigger because we made sure of it in this block right here. So if A is in the proper range, we return it. If A is not in the proper range, then we return B. And we return B, and we know that B is in the proper range because if we already checked to see if neither was in the proper range over here. Okay, and it looks like we're coming up on about 30 minutes. I started my clock a little late, so I think it was a few minutes late. So we're going to go ahead and pick up with string E on the next episode. And if you haven't gotten that far, go ahead and try to work that one and then the ones after that. I think we're almost done with warm-up. Yeah, we'll go ahead and finish warm-up on the next episode. Go ahead and try to do all those, and we can compare answers. And then we'll get to warm-up 2. Thanks for tuning in, guys. Appreciate you here at Cajun Coding. And I'll see you next time. Like, subscribe, have any comments, questions, or suggestions, requests, I'd be glad to see them. Talk to you later. Bye-bye.